Hey everyone, in this video I'm going to be talking about writing Arduino code so that we can finally turn on our LED. So the big thing about this chapter is that if you're unfamiliar with code, it's actually totally fine because what you'll find is that Arduino code is actually kind of its own little world. So even though it is C++ code, you will probably need to relearn a little bit of what you know, even if you know C++, because a lot of the ways the Arduino structures its code is very different from what you're normally used to, especially if you're coming from some programming knowledge. So let's see how we can turn on our LED. So the first thing I want to show you is this diagram that shows the Arduino code layout. Now there are these two chunks, which we call functions, but I'll call them chunks for now. These two chunks of code that an Arduino runs. The first one is called setup, right? This setup here. Ignore the parentheses and this void word for now. We're going to talk more about that in future videos on what that means and how we can change it. So we have this setup chunk, and then we have this loop chunk, right? So there's two different things happening here. Now it's important to understand what each part does and what the differences are. So let's talk about that. So the things that happen in setup really deal with telling the Arduino what you have connected. So the first thing is you're going to want to tell the Arduino the digital pins that you're working with, right? So if you remember from our LED wiring, we connected the LED to digital pin 7, right? So that is the pin number. Now let's think about whether or not this is something that's an input, something that gives data to the Arduino, or something that's an output, something that the Arduino has to basically give signals to. Now from the Arduino's perspective, is the LED getting any signal? Like, is the LED sending any signals to the Arduino? The answer is obviously no, right? The LED is just turning on. It's not sending anything to the Arduino, right? So we know that the LED is an output, right? The Arduino is sending signals to this output to turn it on. So setting up the pin number, telling it whether it's an input and output. Then the other thing to know about setup is that this runs exactly one time before loop is run. Now you're wondering, well, why do I care that it's run one time? I mean, that kind of makes sense, right? Well, because there's something unique about what happens in loop. So in loop, code starts at your first line, then it runs all the code, and then it ends at your last line. But the unique part, and the reason why it's called loop, is because it's going to go back to the start again, and then run your code again. So it's going to repeat, and it's going to continuously run all the code that you write in loop until your Arduino unplugs. And so the key thing to realize here is that code that is written in loop is really going to be your main area where you write code, and it's also going to continuously repeat. And we're going to see why this is actually kind of useful towards the end of this video. So again, we have setup, runs once, tells the Arduino the digital pins you're working with, and then we've got loop, which by its name runs repeatedly. Okay, cool. So let's see how we can write code for each of these parts. So let's go back to our circuit here, and let's toggle this code window. One thing that I want to emphasize here is make sure that you're in the text option. Okay, so I'm going to delete kind of this code that it comes included with, because we're not dealing with that. And one thing I want to introduce you to that I think is going to be very useful when you code is something called a comment. So what I just did there was I typed 2 forward slashes, and then I wrote some text down. Now, what's nice about the 2 forward slashes is it basically tells the Arduino that anything you type along the line that contains 2 forward slashes is basically just going to be ignored by the Arduino. So I could type this as a comment, and the Arduino will just simply ignore it because it knows to ignore it with the 2 forward slashes. So you might be wondering, well, why are comments useful? Because it helps you take notes within your code. And this is super important when you're getting started because you want to make sure that every line you're typing out is commented so you know exactly what's going on. So we're going to do exactly that. So the first thing that we need to do, I'll write step 1, tell the Arduino about the LED, its pin, and then I'll add another comment here. So we're going to tell it about its pin and whether it's an input or an output. So we have 2 main things happening, right? And there is a function. Now, for those of you that don't know, a function is essentially this chunk of code that does a whole bunch of things, but you give a function a name, kind of like a loop or setup. You give it a name, so all you have to do is just type out the name and it'll handle all the work for us. So we don't really care how to tell the Arduino, what pin you're working with or whether or not it's an input and output. We just use the name of a function to do all that work for us. So the name of that function is pin mode with a capital M. And the first thing that you want to do is you open basically a parentheses, right? So left parentheses, and then you type out the pin number, which in this case is 7. Then you separate that with a comma, and then you type whether or not it's an input or an output in all caps. So it's an output. And then you close the parentheses and add a semicolon, and that tells the compiler, or the Arduino rather, that, hey, okay, I finished my line of code. So that's it. That's all you need to do to tell the Arduino about the LED, right? So its pin and whether or not it's an output. I'll put this in a semicolon because that looks more correct. Okay. Now the next thing that we want to do is turn on the LED, right? And in order to do that, if you remember correctly, digital pins have a high or a low signal that's synonymous with on and off. So in order to turn the LED on, we need to send a high signal. In order to send the high signal, we're going to use another piece of code that's going to help us out to do that. And that code is called digital write with a capital W. And you're going to digital write the pin 7, and you're going to set it to high. High, which of course signifies on. And that's it. These two lines of code will turn on this LED. So if you start the simulation, we can see that the Arduino plugs in. Code is loaded onto the Arduino, we see that it's on, and we see that the LED is on. So now at this point you might be wondering, okay, so I have these two lines of code, right? The first one runs in setup because that tells the Arduino what the pin is about, and then in loop we actually do the work of turning it on, which, okay, hopefully that makes sense. Now you might be wondering, like, okay, isn't this kind of pointless? Because if we look at the battery circuit, right, the battery circuit was really simple, right? Like, you could just plug in the LED. Of course, you needed a resistor, but you just plug it in, start the simulation, you're done. No need for these code or anything like that. No need for the breadboard to make it easier on us for Arduino. Like, it seems really complicated just to do the same thing. So what is the point, right? Why do we care? And the reason why we care is because we can start to introduce complexity without changing the circuit and only changing the code. So the next thing that we're going to do is figure out how to turn on the LED and then blink the LED. So we want to blink this LED, right? So let's talk about how blinking works, right? Like, what's going on, right? So we turn on the LED for a set amount of time, then we turn off the LED for a set amount of time. And then that process repeats, right? It turns on, then turns off, turns on, turns off, turns on, turns off, right? That repeats. So it kind of sounds like loop is going to be helping us out here, right? So we already have code to turn on the LED, right? So this is turn on the LED. Now we somehow only want to do that for a fixed amount of time. So how do we tell the Arduino that? Well, we can use something called delay. Now, delay is kind of exactly what it sounds like. It's going to tell the Arduino to not do anything and not change anything in sort of a technical aspect. But all this is doing really is telling the Arduino to wait. Now, the number that you pass in is in milliseconds. So let's say I wanted to wait for 1 second. I can put in 1,000. And that's exactly 1 second. So wait for 1 second. Second. Okay, so we have it on, and we can do it for 1 second. Now, we need to turn it off, right? So let's use digital write, and then 7 low. Let's just turn off the LED. And then finally, right, you might be thinking, like, isn't that it? Well, no, think about it, right? If I digital write high, and I wait 1 second, but then I digital write low and turn off the LED, but I don't wait, I'm going to jump back to turning on. So what's going to happen is it's going to go low for a really, really tiny amount, and then it's going to go high again. So if I ran this, look what happens. We don't actually see it blinking, right? Because the LED turns on. We tell the Arduino, okay, preserve that on state. Don't change anything. Let's leave it on for 1 second, then turn it off. But the issue is that it immediately goes back to turning it on, right? So there's no moment where the LED will actually be able to sustain that turning off because we're not giving the Arduino enough time to do it, right? The whole point of why we wrote delay was because we give the Arduino enough time to process whatever it was doing before, right? Hence, we wait for 1 second. So we're going to have the same delay of 1,000 right here. Wait for 1 second. Okay, now we're going to start simulation, and we see that, all right, It's turning on, then off. On, wait, off, wait. On, wait, off, wait. And that's kind of the pattern of what's going on here. So let's just recap, right? The whole point of why the Arduino is so powerful is because with code, you can take your circuit to the next level. If we wanted to implement this blinking with just a battery, we would need to wire an external switch, and then someone would need to turn the switch on and off repeatedly in order for you to get the blinking effect. But here, it's happening all by itself just with 3 extra lines of code, and I didn't even need to change the circuit. So that's why the Arduino is so powerful, because you can manipulate circuits in very different ways without needing any additional circuitry, and it's just a matter of using your code wisely. So that covers turning on our LED and blinking it. Thank you so much for watching, and I look forward to seeing you in the 3.4 video.